Hello and welcome to the final episode in our Decom World webinar series, brought to you in collaboration with Lloyd's Register. My name is Owen and I'll be your chair, and as many of you know, I'm responsible for producing the Decommissioning and Abandonment Summit, of which Lloyd's Register are one of our gold sponsors. There are over 500 of you guys all signed up today, so thanks very much for the great response, and in advance, thank you to all of our panelists for taking the time today. Just a small bit of housekeeping before we begin. The webinar will last about 45 to 50 minutes, and it's all being recorded, so you'll get the full audio recordings, presentations, and everything within a week or so. You do have the facility to ask questions through me, and there'll be some live polls throughout, so do watch out for those. The purpose of today's session really is to take a closer look at some of the major issues surrounding facilities removal, rigs to reef, and the energy transition. And joining me today to discuss these are James Wiseman, Senior Deepwater Project Manager at Noble, Jamil Pantabrick, Decommissioning Engineer at Petronas, Jacqueline Vasson, the GM at Next Step, John Cox, Decommissioning Manager at Worley and Texi, and then also Judy Copland, Head of Production Technology, and Steve Gilbert, Director of Asset Management and Decommissioning, both at Lloyd's Register. All of the organisations involved today will either be speaking or sponsoring at Decom World, so if you'd like to meet them in person, then do join us in Houston later next month. Without further ado, really, I'd just like to pass over straight off to Steve at Lloyd's Register to discuss a little further.
Thanks very much. Just a little bit about Lloyd's Register before we start. We're a global organisation that employs about 8,000 people, and our prime function in this world is to sort of advance safety and introduce the understanding of public risk. In terms of our services to the energy industry, we cover a broad spectrum all the way from early stage offshore geo survey and engineering work through exploration, production, and ultimately through into the abandonment and decommissioning of oil and gas fields. Our point today really is a general challenge to the received wisdom regarding the decommissioning of unused offshore structures. The default condition here is that we reuse, recycle, or final disposal on land will generally be the preferred option for decommissioning of offshore installations in the marine area. And this is a direct quote from the OSPAR regulations. Now, our view is that this base assumption is worthy of examination and potentially worthy of challenge. If you view the decommissioning of a field in its entirety, then rather than a series of components, you can see that there are various bits and pieces to this field. There are wells, subsea architecture, pipelines, waste piles, cuttings, etc., structures and topsides. And all of these present their own challenges and are subject to varying criteria for removal. And if I refer you back to the OSPAR decision, really it's only relating to structures and topsides when the entire removal of the infrastructure is required. Under generally speaking, all other circumstances, wells, or part of the well at least, subsea architecture, pipeline or some part of the pipeline, and certainly waste piles will remain in place. So that is really the basis of our challenge as to what stays and what goes. And over to you. Thank you.
Yeah, great intro. Thanks, Steve. First, I think we should definitely go to James Wiseman at Noble. He's got some interesting points there to kind of draw out of that, really, around kind of reduce, reuse, and recycling. So James, over to you.
Thank you, Owen, and good morning and good evening, everybody on the line. Just introduction quickly, I'm James Wiseman, a Deepwater Project Manager. So I'm one of the operator perspectives, and I've been working in the offshore field for over 20 years. I did some decommissioning early on when I started in the oil business. Quickly talking about why is decommissioning so hot right now. My view, personal, not my company, is that with the shale revolution, that the oil prices are going to stay low for a while. And as in the past, when I started working in the late 90s, prices were very low and decommissioning was very, very fast paced and a lot of activity. But then when the oil price picked up, the issue sort of went away, and now it's back again to stay. So we really need to solve this. I use the 3 R's approach in planning, and that's reduce, reuse, recycle. For me, one of the things we've learned in the oil industry in the last 5 years is that the production facilities that we design and deploy, they need to be reduced down to a minimum technical solution of what will work. And so that means less carbon intensity in what we put offshore, as well as less scope, less things, and overall it makes the projects effective in a $50 oil price environment. So when I talk about reduce, that's really what it means for going forward in the future, that everything that we put offshore should be minimum technical solution. And on reuse, I won't speak too much to the reusing for the energy transition because I think that's coming up. But reuse for me is all about rigs to reefs, and I've been diving since the 90s and have led it and done many dive trips offshore at the Flower Garden Banks National Marine Sanctuary, which it coexists with oil and gas production in the Gulf of Mexico. And on each of those trips, we get to dive underneath an offshore platform. So, for people that are coming from the North Sea and other environments where it's kind of too rough or no opportunity to dive under the platforms, they don't really get to experience how obvious it is that the platforms are already a reef that needs to be, remain as a reef. And so I'd encourage access. I think with all of the VR systems that we have right now and the observation ROVs, we need to get people's eyeballs on what the platforms look like underwater so that we can reuse them as artificial reefs. And I think we probably can do that worldwide. And we can have a gallery of images and video for people to peruse and maybe even control the vehicles. And then finally, on recycle, rigs to reefs to me is the ultimate recycling. And the way I read the OSPAR statement, as long as it's repurposed, it should be able to be redeployed as a reef, whether it's where it exists currently or moved to a different location. And, that was one of the things I researched when I was in graduate school. I graduated with my master's in '98 when OSPAR was coming out. And unfortunately, we were asking all these same questions, but it was 20 years ago. So now that the 50 forever, that's oil price, if that's going to stick around, we really need to solve it. And finally, the onshore recycling, it sounds great. I really think it's cool that the facilities are being built on the east coast of the UK and in the North Sea sector. But I was in California when some of the platforms were brought in for recycling, and honestly, the people in the area did not appreciate the biofouling and the odor one bit. And they thought recycling was great, but as long as it was nowhere near them. So I really thought that was unfair. And if we want to recycle the facilities, which we do, we need to tackle that as well. So really, that's my 5 minutes worth, Owen.
Yeah, no, that's interesting. I mean, that diving under the facilities as well sounds like a lot of fun as well. But you mentioned rigs to reef as well. I know, Jamil, you've been doing quite a lot of work for Petronas with regards to kind of rigs to reef in Malaysia. It'd be interesting to hand over to you now, really, and to kind of discuss some of these things a little bit further.
Right. Thank you, Owen. And thank you to Decom World and Lloyd's Register for organizing this webinar. Glad to be here today. So let me get started with this. So I'm Jamil Pantabrik from Petronas, Malaysia's national oil company. And today I'll be focusing on reefing and how we are approaching this topic in this part of the world. So in Malaysia, there's only been a few decom projects, and they've all been quite expensive endeavors. And moving forward, we're kind of looking at ways of being more efficient and thinking differently on how we can better manage the liabilities around decom, while at the same time reducing costs. And we're also looking at opportunities around collaboration with parties that are not necessarily linked with oil and gas, and that's where ideas like reefing and repurposing are really being seriously looked at. So with artificial reefing, we've been collaborating closely with the Department of Fisheries, looking at addressing some of the current problems that we're facing today. And the main one is in Malaysia is a serious issue with overfishing, and that severely affects fish stocks, which jeopardizes the marine ecology and food security in the region. So efforts are really needed to rehabilitate and normalize fish stocks as much as possible. And if you think about it, when the government has been doing reefing for decades and is embarking on artificial reefing programs right now and spends millions on it, would it not be the perfect solution to get it donated for free, essentially? And this is where reefing platforms, I think, comes into the picture. So in Malaysia, I think there's a greater case for reefing in tropical environments due to the high abundance of species and the fact that most of the platforms here are in shallow water. If you compare that situation with North Sea, for example. And 30 to 40% of live coral cover on islands in Malaysia waters. So there's a great potential there for coral seeding. So these coral areas, basically the coral planula larvae get dispersed and attach themselves to substrate that happens to be in their path. So the fact that we have these coral seeding sources quite close to these oil platforms really gives potential to rigs to reef. And we find that when we're doing our comparative assessment, the DCOM option assessments, we find that it overwhelmingly favors the reefing option due to the overwhelming benefits of keeping the marine biota intact. Right, case can be made at water depths deeper than 40 meters. So generally we regard about 30 to 40 meters as the perfect water depth for reefing. But what we're finding is that this is not exclusively the case. So some of the platforms, we found evidence of hard coral cover in over 60-meter water depth. And what's even more surprising is that these platforms are in locations nowhere near where we would expect coral seeding areas to cover. So that points to existence of unknown coral seeding sources. So I think that's really interesting development and it's worth exploring further. And that's really what we're doing currently with our R&D arm to further explore, especially on the viability of reefing in situ. So when it comes to reefing in situ and reefing in deeper water depths, I think what's needed is a solid scientific argument behind it if you want to pursue it further. And I mean, we have a lot of data from our underwater inspections, but they've got their limitations. So the survey methodology is more catered to surveying platform structures, obviously. So it's worth looking at whether we can conduct surveys specifically for marine life. And that's what Petronas is looking at right now. But of course, proper waste management, removal of non-reefable material, and doing the proper hydrocarbon free of the platforms is crucial. And obviously, we're not going to reef every single platform, so we really have to take care of the environment in this aspect. Because if we're going to introduce something artificial into the ecosystem, it's essential that we don't end up doing more harm than good. So this really shows some of the diverse fauna that we've captured in our surveys. And what we can see is that the abundance and diversity of species doesn't just exist in the first 30 to 40 meters of water depth. The first two pictures you see post-reefing surveys conducted after a couple of months. So within 2 months, you're already seeing a high diversity of species aggregating at the site. And these post-reefing surveys are really important as quality assurance. So after the reefing is complete, it shows that we've done the reefing properly and there's no significant changes from the baseline assessments. And it also shows the reefing has shown promising preliminary results in attracting marine life. When it comes to repurposing, some challenges remain, but we're always looking at in this area. So quite recently, we've collaborated with a local university and identified a suitable platform to house an oceanic research station. So as far as I know, this is the first of its kind. And it's a pretty cool idea, but you have to consider things like residual liability. So ultimately, who is responsible for the platform at the end of life? Because someone still has to decommission it in the end. And then there's the issue when you transfer to a non-oil and gas entity. So how much they really understand the issues surrounding the maintenance of the structure and the HSE issues involved. So these are some of the issues that need to be ironed out. So I think that's it from me. Thank you very much. Over back to you, Owen.
Yeah, no, that's all really interesting. Thanks, Jamil. I mean, I know it's really interesting to kind of hear a bit more what's going over in Malaysia. I know John Cox at Worley's been looking in a little bit more to kind of some of the BSI guidelines and over in kind of the Gulf of Mexico and things. I mean, probably a good time to pass over to you actually, John, to kind of flesh those things out a little bit more for us.
Thanks, Owen. As Owen said, my name is John Cox and I'm with Worley Intexi and I'm the Global Decommissioning Lead. I'd like to thank Decom World and of course our partners at LR for giving us the opportunity to participate in it. My slides really, as Owen said, carries on from basically what James and Jamel have just said. And give some numbers specifically in the Gulf of Mexico. And I'd like to think BSI is a fantastic source of information for this. But it will go on to show why you can't always do 2 weeks to reefs. So if I can get this to work, which is always an issue, can all platforms be reefed? I think the answer, according to BSI and general knowledge, is no. No, there are engineering environmental standards for converting a platform to a permanent artificial reef. The size, complexity, the initial integrity, and of course, looking at the seabed. Gulf of Mexico, where the majority of the reefing has been done recently, is perfect. It's flat, it's plain, as it says there, clay, mud, and sand. And it's a fantastic area to put in a steel substrate that becomes a reef. So the Gulf of Mexico particularly is good. And not all areas of the world are, but the guys in Malaysia, absolutely, like the Gulf of Mexico, is a very good environment to do that, as is the coast of California. What are the benefits of reefing? Well, as it says there, and again, I thank BSI for this, a typical 8-leg structure provides home for 12 to 14,000 fish, according to the study by the Coastal Marine Institute. And a typical 4-legger structure can provide 2 and 3 acres of habitat for marine species. And going on for what James says, getting the general public's eyeballs down into the water to see, especially off the garden banks here in the Gulf of Mexico, I think would bring this subject clearly into the public domain and would allow emotions to be taken out and would allow people to understand that potentially, as I said, not all platforms can be done this way, that the substructures can be reefed and there can be benefits from that. From a repurposing, from an environmental point of view, and we've got to look at emissions these days, especially when working in areas like California. Repurposing obsolete structures reduces fuel emissions. It doesn't get rid of them, it reduces them due to the reduced marine spread of towing something to the beach and then cutting it up, as well as the obvious health and safety advantages of not cutting something up in place. For oil and gas companies, repurposing obsolete structures does not eliminate the cost of removing, transporting and disposing of them. So if people go and start spreading that this lets the oil companies off the hook, it does to a certain extent, but it reduces the cost. It doesn't eliminate them. Again, going up to the point above, all it really does is it reduces part of the tow that you've got to do, because a lot of these have to be, especially in the Gulf of Mexico, need to be moved to designated reefing sites. For states, and this is United States specific, artificial reefs attract marine life, as we stated above. They enhance its fisheries, as I said above, and contributes to the economy by attracting recreational, commercial fishing and diving. I think James touched on the diving. The GOM is gin clear, so it's great for sport divers and sport fishermen to actually work and play in this area. So it becomes a natural resource, albeit an artificial natural resource. For commercial fisheries, artificial reefs create a rich diversity of marine life. I think this can be seen by the pictures, which are actually from the Gulf of Mexico. Pictures to the right above is a riser, set of risers, on a jacket, and the picture at the bottom right is a jacket that's actually been left in location, reefed in location. So what does it offer? We've just done some work in California, and there were studies to show that for marine species, the platforms themselves, even before they become artificial reefs, provide habitat, shelter, food, and other necessary elements for biodiversity. There is an example that a certain species of fish was fished to within a small percentage of sustainability. A moratoria was put in place around these jackets, and the fish population rose year on year by 5% above sustainability. So there's evidence to show, scientific evidence to show the benefits of leaving these in place. So what have we done in the GOM? And again, thanks to Bessie for this. As of April 15, 2018, 532 platforms that had been in the GOM on the outer continental shelf have been reefed, including, as you can see from the top right hand, the Red Hawk Spar. Occidental Anadarko at the time got permission to reef one of the first spars that was intentionally reefed in the Gulf of Mexico. As I said, not all platforms are suitable for reefing. Again, we have to look at it. It's an engineering exercise. Size, complexity, structural integrity, all contribute to whether a facility can be reefed or it can't be reefed. Now, OSPAR insists that everything comes out. The last slide I want to show just proves that not everything's taken out. Rex in UK waters, and Trinity House supplied this information, and this is just for the latter half of the 20th century and into the 21st. 150 wrecks in UK waters, 74 of which, by the way, are in Scapa Flow, which is the Imperial German fleet, and are in fact war graves, but can't be removed. Few, if any, of the above have been recovered. As I said, the war graves obviously wouldn't be, but many still contain full fuel bunkers and pose a potential risk to the environment. There is hundreds of thousands of tons of steel already laying on the bottom of the North Sea. And as that picture shows, it encourages reef growth in the North Sea as well. Obviously, we're not condoning dumping, and we wouldn't condone just dumping any platform. We are all stewards of the environment, and at this stage, we are not considering topsides to be reefed, just substructures. And I know Petronas are looking at expanding that. So if you can effectively clean dumb iron, clean the risers in the dumb iron, take out some piles, then I see no reason where all criteria can be met that OSPAR should not be revisited, and the idea of leaving in place should not be considered. And I also believe that the Insight organization are doing some valuable work on this, looking at coral growth. So that's my 5 minutes. That's my reasons and not my company's reasons why I think that reefing in place or designated reefing areas is something that needs to be considered. So I will hand back to you, Owen.
Yeah, no, that's all kind of really interesting stuff. And I guess the most natural kind of question that flows off that when you do kind of begin to highlight some of the quite obvious benefits of reefing really is kind of those barriers and the kind of hurdles that must be overcome to really kind of achieve more reefing, really. So I'm going to pop up a polling question actually for everybody within the audience. Do have an answer to that, and we can have a look what you guys think. But just while we're waiting for that to come in, it would be interesting to hear, I guess, from you, Jamil. What would you say really, is there such thing as a perfect reefing site? Is there a certain type of facility that is more suited to reefing? Kind of what would you think on that? Or John as well, if you wanted to jump in.
Yeah, Jamil's muted right now.
Right, sorry about that. So over here, we work with the Department of Fisheries quite closely to come up with suitable reefing sites. So oftentimes they're pre-selected. And how we go about selecting these sites is ideally, they should be close to existing coral fields so that they can get the full benefit of these sources of coral seeding. 30 meters to about 40 meters water depth. So that's been shown as the most optimum for reefing. Any shallower and it would not be suitable due to UV sunlight. The seabed should be conducive and not encourage settlement of the structure into the seabed. So a muddy seabed, for instance, is a no-no. And then you have other characteristics that you look at, like the seawater temperature and the current. But really, if you have evidence already that coral reefs are nearby, then that's even better. So yeah, that's my 2 cents.
Okay. Yeah. No. Interesting. I mean, yeah. I mean, most of us have actually.
I think you also have to be careful with regards to the types of coral. Brazil's got an issue with sun coral, which is a non-local species and in fact an invasive species. So you want to be careful of moving things to different areas and making sure you don't bring invasive species that can do more damage to the environment. So you have to get your environmental engineers to look at exactly what the fauna and flora is subsea to make sure that you're not in fact creating a problem to the indigenous flora and fauna that are subsea by bringing in some invasive species from another region. So there has to be more than just structural engineering and looking at seabed conditions. You have to understand exactly what the growth is and what that growth affects if you move it into another location.
Sure. Yeah, absolutely. I mean, I'm going to pop up the poll questions. It looks like most people have responded, but did anyone else want to jump in before we kind of move on to the poll?
Well, sure. I've got a perspective on it. I think which is it's not the answer is regulation, but the hurdle that I see is the somebody needs to own the reef, and at this point, people are really shy about owning a reef. But if it's an asset and a national treasure, then the country should be happy to own it.
Absolutely, absolutely. Those answers kind of should be up on everyone's screen now to see. I guess Steve and Julie, is that kind of what you guys at Lloyd's Register would have thought the answers would be? Do you agree those are the biggest hurdles to rigs to reef? Kind of what are your thoughts?
Yeah, I mean, we thought that those two were going to be the highest. Public acceptance, definitely, and regulations, absolutely. I think they're the two biggest hurdles that we have to overcome.
I think one of the challenges you've got is that when we talk about reefing, there is always a perhaps pervasive suspicion that what people are looking to do is run away from their responsibilities. So there is quite a big job to convince both the kind of general public and the regulators that it's actually the right thing to do.
Yeah, absolutely. I mean, John and Jamil as well. Then, obviously, kind of off the back of your presentations, is this something that you would have thought as well? Obviously, regulations and public acceptance sound like they're the big things, but technology, money, are those are these results that you'd agree with, or kind of what would you suggest?
Yeah. So
I think is exactly what we'd expect to see. Exactly what we'd expect to see. I mean, to the lower points, and I think I covered it when I spoke. I think we need to take the emotion out of this as well, and let science speak. And as James said, show people what actually grows down there, and then you get some of the emotion out of the way. Then you just have to deal with the other two subjects.
Sure. Yeah, no, it sounds like we've got a very knowledgeable audience then tuned in today as well. So that's all really interesting stuff. I mean, I'd like to pass over next to Jacqueline, the GM at Next Step. I know they've been doing some interesting stuff around platform repurposing and kind of leaning into the energy transition within the Netherlands. So yeah, over to you, Jacqueline.
Okay, thank you very much. My name is Jacqueline Vaas. I'm General Manager of Next Step, and that's the Dutch National Platform for Reuse and Decommissioning. We're a membership organization, and our members are the owners of the Dutch oil and gas infrastructure, which are the 11 operators active in the Netherlands, and EBM, the state-owned, the representative of the state, as 40% of the gas infrastructure in the Netherlands is owned by the government. If we look at the Netherlands, we have quite an extensive network of oil and gas infrastructure, which approximately has as many installations, wells, and pipelines offshore and onshore. The only difference is that the removal of it will cost 500 5 billion euros on the North Sea offshore and 2 billion euros onshore because of impossibilities and extra difficulties removing infrastructure at sea. Aim of Next Step is to reduce cost of decommissioning by 30%, but our other objective is to look at how we can reuse parts of our existing oil and gas infrastructure in view of accelerating the energy transition. Then we're looking at several options. All in all, we investigated 9 options. The first one, which is not really reuse, but is a prerequisite to make reuse possible, that's electrification of platforms. We're now looking at a case to electrify 10 of our biggest platforms, which would reduce the CO2 emissions by 1 million megatons of CO2, which is about 1% of the Dutch total emissions. And it also would lead to 6% extra gas being brought to shore. It's a prerequisite for reuse because without electricity, it's not possible to produce hydrogen, which is our option 2, and it will also not be possible to store CO2, which is our option 9, because we need to compress and heat the CO2 before we can bring it down into the well. I see another presentation now coming up. The fourth possibility.
If you share the screen now, Jacqueline, it will come up.
Yeah. The fourth possibility we look at is an onshore one, and which is repurposing onshore wells into geothermal doublets. As you look at number 7, that's the reefs, but in the Netherlands that's very difficult because we have very shallow waters, and reefing jackets will immediately lead to making it impossible to fish over there. So up to now we have not yet been able to make the reefs. And we had one experiment in which there were 3 identical jackets, and was supposed one to leave it completely, one to remove it completely, one leave for half, and the other one leave it completely, and then see what the difference on the ecosystem would be. But that one did not come out because of the impossibilities in legislation. So for me, the legislation is the biggest hurdle in making possible rigs to reefs. These are possibilities we are looking into. So these 40 other ones we have considered not being economically viable or not being able to make it through the legislation. One of the conclusions we made in our first Reuse and Decom report was, if we look at the infrastructure being removed, which is the blue line, and the availability of reuse, and in this case that's the availability of CO2 to store in depleted gas fields, and we see a big gap. And we see that in the next decade, about half of our infrastructure will be removed, and it will take more than a decade before sufficient amounts of CO2 will be available for capturing in depleted for storage in depleted gas fields. So that's one of the messages we're giving now to the ministry. Mind the gap, and that means either we have to accelerate the capture of CO2 from the industry, or we have to preserve crucial infrastructure for the future. And that's what NextStep is doing right now, trying to make a roadmap where is the crucial infrastructure for making possible what we are willing to do. One of the project we're working on at the moment is the Poseidon project, and what you see on the picture is Q13A, which is an oil and gas producing platform of Neptune Energy. And we're now preparing a project which should be starting this summer to place a 1 megawatt electrolyzer on the platform, just to build up experience, because electrolyzer technology has never been tested offshore, and to make sure that by 2030 we can install gigawatts of electrolyzers offshore. We really need to make sure that the technology is ready for that. So we have to start with experiments now. So I'm very happy that we, together with several other operators in the Netherlands, as next step, we're going to execute this project. And this will be for me. So back to you, Owen.
Yeah, no, that's interesting. I have a question really coming straight off the back of that, Jacqueline, but I'll launch our second polling question while you answer. It'd be interesting to know from everyone tuned in what percentage of offshore infrastructure is actually suitable for repurposing. So that one's up on the screen now. Jacqueline, I know you mentioned the Poseidon project right at the end there. How successful do you think offshore hydrogen will become then, when you look kind of 10, 20, maybe 50 years down the line?
Well, if you look at it now, it's not economically viable, but if you look at the development of offshore wind energy, 10 years ago, you were not able to build a wind farm offshore with large grant of the ministry, and now they can be built without any subsidy. And in my view, it will go the same for hydrogen. We have to build up, we have to knowledge, we have to innovate, we have to improve the technology, we have to scale up, and then costs will come down. And if we look at after 2030, our TSO tenets is that they can bring up to 12 gigawatts to shore. After 2013, the wind farms will go over that 12 gigawatts, and then you are not able to bring the electricity on shore anymore. Then you should do something with that. And even the further away wind farms go from shore, the more expensive it will become to get the electricity on shore, which makes the business case for offshore hydrogen production much more favorable. So I see definitely a bright future for offshore hydrogen.
Interesting. It looks like we have a winner on the poll as well. So I'm sure you can tell us if people are correct or not. With almost half saying 10 to 20% suitable, and then kind of a split between the hires. Nobody's thinking over 60%. But Jacqueline, do you have the answer for us on that one?
What we have, our current estimate is that we can reuse 10% of the Dutch platforms for hydrogen production.
Interesting. Yeah. So once again, it looks like our audience are quite clued up on that one. I mean, panelists, is that something? Is that kind of the figure you would have thought? Is it more? Is it less?
Can I comment? This is James. I think it should be much higher. I think people are disregarding the fact that many of the wells that we're plugging every year could be used for carbon capture. And we design a lot of wells with high chrome tubulars, which means that it would be okay to put CO2 into those wells. And they're not included really, I don't think, in people's thinking.
Okay, yeah, interesting. Could you tell us a little bit more about those? Is that something, you say that you've been looking into, or with regards to kind of carbon capture?
Well, it's just one of the things that's prohibited by regulation right now, is that the wells need to be plugged, and it's a permanent plug and abandonment, and cut the well head off. So it's an irreversible plug and abandonment right now. And I haven't researched it very much. I just think it's something that the general public doesn't know about.
Yeah, no, it's interesting. I mean, it plays into kind of... Yeah, Jacqueline, do go.
If you're going, at the moment in the Netherlands, we have 2 projects going on CCS. One is the Portals project, which is around the Port of Rotterdam. and it will go to FID the end of this year. So it's really becoming very concrete. And there's a second one starting around the port of Amsterdam and Tata Steel in Amuiden, the big steel producer. And what we see is that you can reuse depleted gas fields and dust the wells to get the CO2 down there. But it's only a temporary reuse, because in the end you still have to plug and abandon the wells when the field is nearing its original pressure.
Okay. Yeah, no, interesting. I mean, off the back of those things, we talk about carbon capture, we talk about hydrogen as well. Obviously, the inevitable question that comes up is obviously around kind of the energy transition or series of energy transitions we're going to see over the next kind of, 10 to 50 years. From a decommissioning point of view, I guess John and Jamil working most closely within that, what role do you think decommissioning plans can play then in supporting the energy transition?
It's like reefing platforms. We have to understand that not every facility can be repurposed for energy transition. There is a kind of myth that's going around at the moment with the general public that all you do is whip the top sides off a platform and stick a wind turbine on top and then run some cables. That's not strictly true. And I think you're going to get into the same issues that Jamal talked about with regards to liabilities of the facility. The facility has still got to be maintained. If it's passed on to another operator who has final decommissioning responsibility for it. So there's still going to be questions on it. We need to move this from 10% or 10 to 20%. As Jacqueline said, 10% is what they think they can use. We need to up that. But we also need to understand that operators, for obvious reasons, are going to try and bend as much life out of the facility as they can before they decommission. So, the last areas of production life, maintenance may slip, integrity maintenance may slip, and you may have a facility that is well beyond its 25 to 30 year life that you then want to make into and give another life. I think there's a lot of engineering work, a lot of integrity work will need to be done to make sure that you have a safe facility that you can move on to in the future. I don't think it's just a case of shutting down, cleaning, and doing a bit of repurposing. There has to be a great deal of work to look at and understanding that, well, from my point of view, not every facility can be transformed into something different.
Yeah, no, absolutely. I know, Jacqueline, your kind of body at Next Step there kind of straddles, obviously, the decommissioning with kind of a strong eye on energy transition as well. Would you agree with kind of John's thoughts there around the kind of potential for all platforms, or in John's views, not all platforms really to be reused for energy transition or for reefing?
No, because we have a lot of satellite platforms which are just too small to reuse for anything. We're also looking at possibilities of reusing platforms as transformator stations for offshore wind farms, but then they need to be in the vicinity of this wind farm. So there are a lot of prerequisites you have to take into account before you can look at reuse, and especially since the platforms in the Dutch continental shelf are relatively small, because we have shallow water compared to like the platforms you have in the northern North Sea, like the Brent or whatever. That's incomparable. So reuse is from platforms, from topsides, is limited. And then we do see a lot of potential in CCS, but then a lot of fields are also too small to make all the investments of making the CCS possible. So also there we see that about 25 to I think 30% of the fields are suitable for storing CO2.
Yeah, no, interesting. I mean, it sounds then like... Owen, we're just talking about platforms and facilities. We've got to remember these are connected by a huge infrastructure pipeline. we have been, especially in the North Sea, we have been using pipelines, not repurposing, but we have been idling pipelines and then bringing pipelines back into service. The Eagle pipeline was a great example. It was originally Hamilton Brothers, Esmond, Forbes and Gordon, which was then tied into Arco at the time, Tyne and Trent. And I know Jacqueline's group are doing an awful lot of work with regard to pipelines and reuse of pipelines. So we have to look at oil and gas infrastructure as a whole, not just see the bit that visibly sticks out of the water, but remember that these are also connected by hundreds of thousands of miles of pipelines and umbilicals as well. And there's potential to reuse at least some of these for either transporting nitrogen or transporting the carbon, if the metallurgy works, back down the wells, as James was saying.
Yeah, no, absolutely. Jamil, is that something that you guys have been looking at as well over in Malaysia? Would you kind of share those thoughts as well around kind of repurposing, or kind of how's that looking over on that side of the world?
Yeah, so if you're talking about for the energy transition, we have been exploring the ideas on renewable energy like wind turbines and using existing offshore facilities for that. Problem is in Malaysia, the wind resource is not like it is in the North Sea, so the wind here doesn't blow like there, and so that idea is sort of not too feasible, but we have initiated a sort of pilot project to see if it would work out. There's been new technology in wind turbines that work a lot better in kind of slower wind speeds. But even then, like the most likely scenario is actually building new infrastructure for the wind turbines and connecting it to existing facilities to use as sort of electricity to replace their gas generators. So we see that even then, like the existing infrastructure is not that suited. So things like issues like structural integrity, the fact that the aging facilities need additional investment for refurbishment and reinforcement, and the additional maintenance that goes into that, it's sort of easier to actually build new, and also the engineering that goes into that as well, like reverse engineering these existing platforms to cater for these, new loads that wouldn't exist otherwise. So yeah, those are some of the challenges we're facing.
Yeah, interesting. We've actually got a couple of questions that have started to come in from people now as well. So do keep them coming, everybody who's tuned in today. This one links back to, I think, what Jacqueline was saying, and it might be quite a short answer, really. But where are you getting the electricity from with regards to the projects that you're looking at? And the question also poses that electrolysis is actually much more efficient onshore. So what's the benefit really of doing it out at sea?
We would get the electricity directly from the wind farms. I think there is the efficiency on an offshore is equal because it will be the same electrolyzer technology, but it will be cheaper onshore because offshore you have more maintenance. But the main advantage is in that whilst we are building wind farms further from the shore, it will be much more expensive to bring the electricity onshore, and the losses will be much higher. And we know that with transporting electrons, you lose 10 times as much as transporting molecules. So in the end, we think there will be a business case for offshore hydrogen production, because it's too expensive to bring it onshore, or the national grid can absorb it, and then it will be worth nothing. So, and if the electricity is free, the business case for offshore hydrogen production will become favorable compared to offshore, where you have to pay for the electricity.
Yeah, interesting. I mean, you mentioned cost there as well. It's something that we actually haven't touched on to a great extent so far. I guess possibly tying to some of the work that you guys have been doing at Lloyd's Register. Do you think the costs of long-term monitoring that kind of come with a lot of these solutions are adequately captured by the current projections that we have? I mean, essentially, if we look at the trade-off between leaving in place and then the kind of savings for long-term monitoring, how do we think that that's going to play out?
Well, I think the premise underlying all this is that what you're leaving behind is relatively benign. I don't think anybody's making the case for leaving the structure in its entirety or leaving behind things that could potentially risk loss of containment. So over a longer duration, the frequency of inspection will get greater and greater, or longer and longer apart. So eventually you'll get to the point where monitoring is probably not required. If you want to talk about potential long-term fits in terms of monitoring, they would be more likely to center around the well stock that gets left behind. And that is an unavoidable residual effect of the oil and gas decommissioning anyway. You can't take the well home with you. That's going to end up being left where it is.
Yeah, absolutely. Another kind of question came in. This actually touched more upon the first webinar that we did with you guys at Lloyd's. But yeah, with regards to Next Step, who obviously went in on that one, are you guys aiming to reach your 30% cost reduction target when it comes to decommissioning? Is that something that these projects that you outlined earlier, Jacqueline, are going to help with, or how do you see that one?
Well, what we do to reach our cost reduction of 30%, which is our goal, we're mainly focusing at the shared learning, so the exchange of knowledge between the operators and in joint campaigns. But we're also working on an innovation agenda together with the service industry. And there we see, because like I said, if you reuse your wells for injecting CO2 into the depleted gas field, eventually you still have to P&A those wells, but it will be a couple of years later, and that might mean that you're able to profit from new innovations which would not have been available 4 years ago if you had to decommission them earlier. So there I also see a benefit in reuse, and also if you can make a couple of years longer use of your infrastructure, that would also benefit and lead to a lower decommissioning cost.
Sure. Another question has actually just come in as well. I guess this kind of actually might be interesting to throw to you, James. I know you were talking about diving slightly earlier, but then obviously it'd be good to throw this one out to everyone really afterwards. But yeah, do rigs actually act as a kind of a biodiverse ecosystem in their own right, or do they really only just serve to aggregate fish stocks that are already in the ocean?
Thanks, Owen. No, that's a good question. I think recent studies have shown that they actually create biomass, not just aggregate it. That's a big thing. That it's pretty obvious when you dive in the Gulf, because the Gulf is mostly soft sediment, and the biomass just wouldn't be there. So there are natural banks which are already loaded up with biomass, and so the platforms in the Gulf create some more. And I'd imagine it's probably like that in most warm water environments, and maybe the cold water environments as well. The thing is, people need to see it to understand, and they're not like a fish attractor device for sport fishing. You'd be surprised, like the artificial reef program in the Gulf, a lot of the platforms there are cut off 90 feet below the waterline, and the fishing pressure on those is very light. I've gone out, and I have a boat of my own. You can dive from it, going out in the Gulf, and I know where those artificial reefs are, and really there aren't any people fishing there. So they're definitely fish producers, because the people aren't removing the fish from those even. So I think once we have a good network of reefs, that they're all generating.
Yeah, interesting. Did anyone else kind of want to add to anything that James kind of brought to light there? We've got other questions coming in anyway. I guess what would be interesting to know from you, Steve, if you're aware, really, what kind of benchmarking measures do you know, if any, really, are being used in the North Sea at the moment to actually prove that the removal option being used during decommissioning is actually a superior alternative?
Well, at the moment, there is really no alternative. I mean, you know, the legislative framework is that everything gets removed. There are certain notable exceptions of things that are being left in place, but that's mostly because right now, we can't really remove them. So there is no comparative structure, if you like, that you could look at. It's not as if some structures were left behind for an analysis on whether they aggregate or even increase the amount of biomass, and then compared to when structures are removed. As it stands right now, anything that can be removed, the mandate is that it ought to be removed. So there really isn't, the experiment isn't running, I suppose, in that way.
Sure. And Jamil, then I guess we've talked quite a lot about the regulations kind of here in the North Sea and touched on some over in the GIM as well. Are any current Malaysian guidelines, are there any kind of, with regards to artificial reefing, how's that looking from a Malaysian perspective?
Right, so currently Petronas is developing its own reefing guidelines for contractors. So that would cover the prerequisites for reefing and kind of like what raw data is needed, handling of non-reef items, considerations when you want to do your reefing engineering, preparing the facilities for reefing and HSE issues and things like that. So that's pretty much more of a guidelines and kind of like a regulatory kind of procedure to help contractors in carrying out reefing programs.
Yeah, sure. I mean, we actually just got a question in as well, which is, I think, linked to what you were discussing earlier around kind of the perfect, if there is really a perfect kind of site for reefing. In the more shallow waters, so kind of anything less than the 40 meters you kind of alluded to, do you think there's any scope for platforms to be dismantled, cut up into smaller sections to account for that water depth, and then be able to spread the flat platform on a wider footprint for a better habitat? Is that something you've looked at all, or is that something that you could see as a possibility?
Well, even platforms that we've reefed before, that's kind of what we do anyway for the smaller kind of support structures and equipment that have already been hydrocarbon free. So it really you kind of have to look at the reefing site as well, the sort of bathymetric data and the contours of the site, and with that you can kind of distribute these smaller sections to create sort of free spans for fish and for marine biota to sort of inhabit those places to make it a more conducive reefing site.
Okay, yeah, interesting. I mean, as I say, we're kind of running out of time now, but an interesting one's just come in actually right at the last minute, which would be interesting to end on. The question suggests that yeah, we now actually have kind of vessels that can lift up to 40,000 ton jackets, and suggests that there's no real argument now to leave jackets or parts in the seabed. Does the panel agree that the IMO guidelines should be updated to reflect this new available technology?
Vessels that can lift 40,000 tons of jackets.
I'm not aware of that, John. Are you?
No, that's an interesting one. When they become and when they exist, yes, absolutely. We should look to remove it. I know Edward Hiram is looking at putting what they call the forklift on the back of the Pioneer and Spirit to lift them out. That technology is still immature. But for sure, but again, you have to look at where are you going to put it? You're going to have to cut it up onshore. I mean, if it's possible to reef it, then reef it. I mean, I'm all for technology, and if this technology exists, and when it does exist, because trust me, all seas will get it to work eventually, then yeah, for sure we'll use it. But again, you have to look at the benefits of bringing it back to the beach over the harms that could be done by destroying what could be an environmental sub-infrastructure that's been created over 40 years. Again, we have to look at it on a case-by-case basis, and we have to do cost-benefit analysis and what harms can be done. But if the technology exists, then sure, let's look at using it.
Yeah, this is James. I'm of a similar mindset. Being an offshore project manager, the market for decommissioning is big enough that Hirama and Allseas and them are going to build something. You know, and the pioneering spirit was in the works for almost 20 years. And, you know, they finally thought that the time was right, and it just happened to correspond with the oil price crash. So that's worked out really well for them. But there are other people, you know, there are a lot of capital companies right now that are funding offshore floating production facilities. And when those stop being built, I think they'll just switch to funding some of these decommissioning assets, like some of those offshore heavy lift buoyancy type facility removal devices.
Sure. I mean, an interesting kind of look forward then to kind of wrap everything up. Apologies to anyone that we didn't manage to get through on the questions. We'll make sure we get those over to the guys at Lloyd's Register, and they'll kind of reach out to you directly with responses, I'm sure. But as I say, yeah, that's all that we've got time for, and we'll have to wrap it up here. As I say, everybody kind of present today, all the organisations on board will either be speaking or sponsoring at the Decommissioning and Abandonment Summit. And if you'd love to hear more from the speakers and the rest of the community, then do kind of come and join us. Many thanks once again to Lloyd's Register, to Steve and Julie, but also, you know, to James, Jamil, John, and Jacqueline. Everyone will have kind of full access to all the audio and the presentations as well. I'll send them all out directly within the week, so share them with anyone, your colleagues, your clients, and the community. We want to spread as much knowledge as possible. So once again, I thank you for tuning in. Thanks to all the panelists as well, and goodbye.
All right, thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thanks.